In this video, we'll be talking about differentiation rules. So we'll start with the constant rule. So this constant rule is part of the basic rules. Now the function, let's say we have a function of f of x being equal to c. And we also have another function which is g of x being equal to x exponent n, where we know that n is a positive integer, are the building blocks from which all polynomials and rational functions are constructed. Now, to find derivatives of polynomial and rational function effectively or efficiently without restoring to the limit definition of derivative, you might first develop formulas for differentiating these basic functions that we talk about. So we'll first start with the constant rule. Now, with the constant rule, we apply the limit definition of the derivative to find the derivative of the constant. So, as I said, let's say we have f of x being equal to c. Now, for this function, both f of x being equal to c and f of x plus h is also equal to c. Now, from this, we can deduce or obtain the following results. So, the derivative of f of x with the limit as h approaches 0. So, f of x plus h minus f of x on h. Then we get a result of limit as h approaches 0, c minus c over h, which when we do that, we should get the limit as h approaches 0 to be equal to 0 on h. And then finally, from this, we can get equal to limit of 0 as h approaches 0 to be equal to 0, right? So the rule for differentiating constant function is called the constant rule, which states that the derivative of the constant function is 0. That is, since a constant function is horizontal line, the slope or the rate of change of a constant function is just 0. So we can restate it in the form of, let's c be the constant, okay? Let's c be the constant. So if f of x is equal to c, then the derivative, which is f of c, will be equal to 0. We can also have another alternative. Which is d on x of c will be equal to 0. That's another alternative way. Okay, so let's look at this example here. Very simple example. So this example, we are going to find the derivative of f of x equal to 8. So this one is just one step application of the rule. Okay, so we use the constant rule. So this answer here will be f prime of x will be equal to 0. Okay, so you can try this on your own. Try this and put your answer in the comment section. G of x equal to -3. Now let's talk about the power rule. Now, from our previous video about differentiation, we showed that d on dx of d on dx of x squared equal to 2x, and d on dx into bracket x exponent half will be equal to 1 on 2x exponent negative half. Okay, now at this point, we might see the pattern beginning to develop from derivative of the form d on dx into bracket x exponent n. So we can continue to examine the derivative formulas by differentiating powers functions of the form f of x equal to x exponent n, where we know that n is the positive integer. We develop formulas for derivatives of this type of function in stages, beginning with positive integers powers. So before stating and proving the general formula of derivative of function of this form, we take a look at a specific case. Let's say d on dx into bracket x cube. So as we go through the derivative though, you note that the technique used in this case is essentially the same as the technique used to prove the general case. Okay, so let's differentiate x cube. Okay, then we are going to use that to find the d on dx s cube. Okay, so with this, so we have solution. So d on dx into bracket x cube will be equal to lim as h approaches 0, open bracket s cube, open bracket x plus h cube minus x cube on h. Then we go ahead and simplify lim as h approaches 0, s cubed plus 3x squared. So we are just simplifying what is in the bracket, x plus h plus 3xh squared plus h 3 minus x cubed on h. So here you can see that the first term is the expansion of the x plus h cube is x cube, right? You can see that. And the second term, which is the 3x squared, this one right here, h. Okay, and all other terms contain powers of h that are 2 or greater. Okay, so let's move ahead. So here we have lim at h approaches 0, 3x squared h plus 3xh squared plus h cubed on h. Then remove factor, the common factor. That's what we did. Then we have lim as h approaches 0. We have 3x squared plus 3xh plus h squared. Then finally we have 3x squared. Okay, so here what we did is that we let the h go to 0. Okay, we let the h go to 0. That is the final answer. So as we shall see, the procedure for finding the derivative of the general form, which is the f of x equal to x exponent n, is very similar. Okay, so now from what we have done, we can deduce a theorem. Okay, so let's say we have, let n be the positive integer. Okay, positive integer. So if f of x is equal to x exponent n, then we can deduce that f prime of x will be equal to n multiplying x exponent n minus 1. Okay, alternatively, you can also have it as d on dx of x exponent n to be equal to n multiplying x exponent n minus 1. That's where. So we can prove this. So let's prove that very quick. So to prove that, we know that we have f of x equal to x exponent n, where we know that the n is a positive integer, right? So the f prime of x will be equal to lim as h approaches 0, open bracket x plus h exponent n minus x exponent n on h. Okay, now since we know that x plus h exponent n is equal to x n plus n x exponent n minus 1 h plus n on 2 open bracket x exponent n minus 2 h squared, right? Then we have n 3 x exponent n minus 3 h 3. Then it can go on and on, where we have x multiplying n h exponent n minus 1 plus h exponent n. Okay, so we can see that the x plus h exponent n minus x n exponent n will be equal to n multiplying x exponent n minus 1 h plus n2 multiplying x exponent n minus 2 is h exponent 2 plus n3 multiplying x exponent n minus 3 h3 plus, which can go on and on, plus n multiplying x multiplying h exponent n minus 1 plus h exponent n. Okay, so next we have to divide both sides by h. Then to divide both sides by h, we will have x plus h exponent n minus x exponent n on h will be equal to n multiplying x exponent n minus 1 h plus n2 multiplying x exponent n minus 2 h squared plus n3 multiplying x exponent n minus 3 h3. Then it goes on and on till when we get to plus n multiplying x multiplying h exponent n minus 1 plus h exponent n, right? Then we divide this long one by h, right? So when we simplify that, we should be getting x plus h exponent n minus x exponent n over h to be equal to n multiplying x exponent n minus 1 plus n2x exponent n minus 2 h plus n3 multiplying x exponent n minus 3 h squared. Then plus it goes on to n multiplying x h exponent n minus 2 plus h n minus 1. Then finally we can deduce that f prime of x to be equal to lim as h approaches 0 to be equal to n multiplying x exponent n minus 1 plus n2 multiplying x exponent n minus 2 h plus n3 multiplying x exponent n minus 3 h squared plus goes on plus n multiplying x multiplying h n minus 1, then finally plus n or h exponent n. So when we do all this, we should get n x exponent n minus, which is n multiplying x exponent n minus 1. Okay, so this is what we get from here. Okay, if you go back here, you can see that. Okay, so when you are given the function, you can see that the exponent, which is n, will come here, then you multiply or you subtract 1 from the exponent, which is the n, then you get your answer. So let's look at this example. So we are going to find the derivative of a function f of x equal to x exponent 10 by applying the power rule. Okay, so using the power rule, which we know that the n is equal to 10, so the f prime of x will be equal to 10, right, x exponent 10 minus 1 equal to 10x exponent 9, right? Okay, that's what we did, that we got the 10x exponent 9. Thank you for watching, and I'll see you in my next video. Bye.